In the second part of stock price prediction, we are going to build, compile, train, and test our long short-term memory model. So let's go. So we'll start building our model, our LSTM model, by using sequential. For LSTM layer, we're gonna give it 15 neurons, and for return sequence it's going to be true, since we are going to use another LSTM layer. To build the LSTM model, first we will call a sequential function, and then second we'll add the layers. Next we'll add the LSTM layer and give it 50 neurons. The return sequence is going to be true, since we are going to use another LSTM layer next. For the input shape, we are going to put the number of steps and features. Then we'll create another LSTM layer with the 50 neurons. The return sequence this time will be false, since we are not going to create any other LSTM layer next. Then we add the dense layer with the 25 neurons and another dense layer with 1 neuron. Next, we'll compile the model using optimizer and loss function. The optimizer is used to improve the loss function, and the loss function, which here we use the mean squared error, it's used to measure how well the model did. Here we are going to train the model using fit, and fit's gonna take the X train, the Y train data, the batch size I choose it to be 1, and the epoch number is going to be 1, 2. Now we need to test our model. So for testing, we're going to use this 30% of the remaining data sets. Remember that we used 70% in the training data, and we're going to use now 30% from the data set to test our model. Here we will create a new array that contain the normalized data, or the 30% normalized data and the data is going to be between the number of samples, which is the training data size minus 60, to the total number of data sets. The y-test will have all the actual data between the training data size to the rest of data, like it's gonna has all the 30% remaining of the data. This actual data, it's the data that we're gonna use to compare it with the prediction. Here we are going to create the 60 observation of our testing data. So using 4, we're gonna go for I, we're gonna go for the range between 60 to the total size of the testing data. We're gonna append X test with the 60 observation. So X test will contain the 60 steps of our testing data. That means which we are going to use in prediction model, and the Y text or Y test gonna contain the actual values. So here, like we did before with the training data, we're gonna do the same for the testing data. So we are going to convert our data to an array and use reshape to reshape the data to 3 dimension. So we can use it in a prediction model. Using model.predict, we were going to generate prediction from our testing data, then to get the predictions, and then we're going to use scalar that inverse transform to get the value of the prediction, not just like value between 0 and 1. To evaluate the model, we'll calculate the root mean square error, so which let us know how accurate the model is. Here the RMSE is 0.8, which is a very good number. Means that the model is accurate and the prediction are matching or close to the actual values. Next, I'm gonna plot the data, the prediction and the actual values. So here we will plot the data so we can see how close the prediction to the actual values. So here we can see like the blue line, it's the training data, which is my 70% of the data, and then I have the like starting from I think around 2018 I have the in green I have the prediction, and in orange it's the actual value. And as you can see, like the prediction line in green and the actual value are almost like the same. They are very like matching and close. So yeah, so we can use this model now to predict any value we need and in any value of stock we want. Let's now print the data in a table. So yeah, so here I can see that the close price and the prediction are really close, except for some dates. They are a little bit like there is some difference, but in general they are both close. That was everything for this video.